Hi again, this is Mr. Wakefield, and we're looking now at complex numbers. And complex numbers go beyond the normal real numbers that we're used to. Real numbers, you guys, are basically all the whole numbers, okay, all of the decimals that are in between the whole numbers and the negative whole numbers. Okay, remember whole numbers are like 1, 2, 3, 4, 5, those types of numbers. Negative whole numbers, obviously, are -1, -2, -3, those things. All the decimals that are in between that, all the fractions you can possibly imagine as well are in that group of real numbers. Okay. However, in order to solve some problems, including some problems that are in that you're going to see here in the future, will involve what we call imaginary numbers, which are separate from real numbers. Okay. The biggest example of that, not the only example, but the thing that kind of brought imaginary numbers into the world, basically, is the fact that, as was mentioned in a different video, you cannot square something. I'm just looking at a problem here from the radical discussion. You cannot square something and get a negative number. That's true in the real number world. That's why it says right here that the answer to this is not a real number, because you can't square something to get -36, and so therefore there is no square root of -36 or any negative number. Okay, but that's in the real number world. However, if you go beyond real numbers and look at what we call imaginary numbers, which I'll explain in just a moment, okay, there actually is an answer to this, believe it or not, okay? And it will actually play into some things that you'll do in the future, some future problems, and so that's why we got to learn it, okay? And so let's go ahead and take a look at that. Basically, you guys, complex numbers are imaginary numbers, okay? Imaginary numbers and real numbers together, if you put them both in a one single group, that's called the complex numbers. Okay, that's why we have this discussion called complex numbers. But we already know now what real numbers are, but what are imaginary numbers? They're inspired by this letter I. The letter I is not actually a variable. It is a constant number, okay? It is the number that you could square to get -1, which normally in the real number world, you wouldn't be able to square something and get any negative number, -1 or any other negative number. But with imaginary numbers, you can. So I squared is equal to -1. I is the number that when you square it, it's equal to -1. So therefore, it would make sense that I is equal to the square root of -1, because when you square it, it's equal to the number on the inside. Okay. And so therefore, we have this thing called the square root of -1. We call it I, though, because it's just easier to say I instead of square root of -1 every time that we do I, every time we deal with I. And so we have this special name for square root of -1, and it's called I. So again, I is not a variable. It is equal to square root of -1, and when you square it, it is equal to -1. Okay, so what we want to do today is we want to learn about how to deal with I in some when it's mixed in with some other things mathematically, okay, including, for example, these 4 problems right here, okay. And as you can see, all of these are square roots with negative numbers underneath. When we dealt with those before, we always said what? We always said that it was not a real number. However, if the problem says express each answer in terms of I and then simplify, when you see those words express each number in terms of I, they are saying that imaginary numbers are now in play. They are now to be considered. You need to consider those. You can't just say not a real number as your answer anymore, at least for these problems. Okay, usually there's exceptions to this, and we'll see those when they come up, but and we'll talk about those. But usually it needs to say that phrase right there, expressing each number in terms of I, and if it doesn't, then you can usually just think of these radicals as not a real number when they have a square root of a negative number underneath. Okay. But when it says express each number in terms of I, this is what we do. Okay, what you do is you go up to this little formula up here. Okay, let's kind of write square root of -21 right underneath it, and then we'll transfer our work down below to where it's supposed to be. Square root of -21. Okay, what it says here is to factor out a -1. I know we don't normally factor out a 1 or -1, but we will in these problems when you express it in terms of I. Okay, you'll see why here in a second. Okay, and then just like was seen in a different video where you can, when you have two things being multiplied together, you can split it up. It has to be multiplication, but if it is, you can split it up like this, okay, into two separate radicals. That's this part. Okay, the b and the 21 are the same thing right here. Okay, so if it's -21, then this part is 21 with the -1 separate. Then we now know that the square root of -1 is equal to I, as it says up here at the top. And so you can change the square root of -1 to be equal to I. So we're just going to take this radical and replace it with I because that's what it's equal to. It's equal to I. And then the square root of 21 is still there. Then if you're able to simplify the square root of 21, go ahead and do so. However, there's no perfect square number that you could factor out of 21. Okay, you can't factor out 4 or 9 or 16. And so that's actually done. If you were able to simplify that, we would do that. We'll see that in some examples here as well. So what I'm going to do is I'm just going to transfer what we have right here. I'm just going to transfer it down here just so that we have that work written down, okay, down here where it's supposed to go. But I just wanted you to see how that formula at the top of the page helped us get the answer. Okay. So the answer is I squared root of 21. So again, we expressed it in terms of I. That's what it means to express it in terms of I. It means to factor out the -1, split up the radicals, and then that first radical, because it's square root of -1, it becomes the I, and you've expressed the answer in terms of I, meaning that you've expressed the answer with I in the answer. Okay, so let's try that again here with square root of 28, -28. Again, we're supposed to factor out the -1. Okay, like that. We then can split apart the radicals. Okay, like that. All right, because they're being multiplied together, you're allowed to split them. Then the square root of -1 becomes your I right there. Let me give myself a little bit more room here because we're going to be doing some more work here. The I, and then the square root of 28. So we express it in terms of I, but they also want us to what? They also want us to simplify if we're able to. Okay, the 28, we can factor out a 4 like that. Okay, notice how I split apart the radicals right away. We saw in a different video where you can do that right away. You didn't actually have to write down this step right here, okay, for the same reason. I just did that because it was at the top of the page, but we already knew that it was going to split apart because they're being multiplied. So when you factor out the -1, you could just jump from this step to this step if you want to save a step there or save some time, okay. But anyway, back to the end of the problem here, we factor out the 4, and just like we always do when we simplify radicals, we then figure out what that number is that was the perfect square number that we factored out. Okay, 4 is the biggest number out of 28 that you can factor out from this list, and so that's why I picked that. That would then be I times, let me write it down up here. I times 2 radical 7. And then when you have a term that's already outside the radical like I, and then you simplify the 28 radical to have an outside and an inside part, 2 and 7, the way you multiply the outside part by the new outside part here is you just multiply this, but you don't multiply by the inside. You never multiply outside the radical times something inside the radical. But you can do I times 2, which is 2I. And so we simplified the radical after we wrote it in terms of I, and that's why we're now done with that problem right there. Okay. So let's try these last two here. All right. Again, and I'll go ahead and skip that step that I was talking about over here. Okay, just to save a little bit of time now that we're kind of used to what's going on here. We factor out the negative 1. We already know it's going to split, so we'll just jump to that step. Okay, this becomes an I. Now, unlike the first two problems, okay, the square root of 16, now normally we would simplify that. But if you're asked to simplify a radical where it's already a perfect square number underneath, and it's just that perfect square number and there's nothing else there underneath the radical, just go ahead and figure out what it's equal to. Evaluate it, okay? As with any perfect square radical, figure out what it's equal to. It's equal to 4, right? And so we just have I times 4. There's no more radicals. This happens sometimes, okay? If there's no more radicals, then you don't need to worry about like what we had to worry about here, where we need to make sure we don't multiply an outside times the inside. There is no inside because there's no radical. So you just multiply these two regular terms together and you get 4i. Okay. Last one here, we just need to be careful with that negative sign that's on the outside. Remember, we're not allowed to multiply the outside times the inside. Okay, and this actually officially means when you have a negative at the beginning of the problem, followed by a radical, that means negative 1 times a radical. But don't be fooled here, you guys. This is you can't do negative 1 times negative 27. Okay, you can't do outside times inside, so you have to keep those two negatives separate. Okay. Now, the negative 1 that's on the outside, that's not the same thing as I, remember. Remember that I is equal to square root of negative 1. It's not equal to negative 1 itself. So the negative 1 that's on the outside, because it's separate from the radical, it's not equal to I, because it's just negative 1. It's not square root of negative 1. So just wanted to clear that up there in case there was any question about that. Okay, so what we do is we do the same thing they've been telling us to do. We bring the negative down. Okay, we got to keep that separate. You can write down negative 1 as well, or you can just say negative, just as long as it means the same thing here. And when I write it like this, it does. Okay, again, we're going to factor out the negative 1. When you just write the negative in front of the radical there, it still means negative 1 times. As long as it still means that, then you can continue to write it in that way there with just the negative, and not you don't need to write down the negative 1 in front of the radical, even though it means negative 1 times. Then we make this I right here. Okay, we know that the square root of negative 1 is I. Negative 1 times I is the same thing as negative I. So that negative 1 that's on the outside, it means the same thing as negative I. So again, this all still has the same meaning as it's supposed to, because negative 1 times this thing which becomes I is equal to negative I. So everything is still correct. Okay, then we, just like in problem B, we simplify the square root of 28. Here we simplify the square root of 27. Okay, so we can factor out what number from the perfect square list will factor out of 27. Okay, 9 will, and there's nothing bigger than that would work for 27. So I'm going to factor out the 9. That would give me 3 here. And then I compute the square root of 9, which is just the number 3. And then just like in problem B over here, after you figure out that the radical is equal to an outside and an inside part right there after you simplify, you got the 2 on the outside, 7 on the inside, you then multiply the 2 outside parts together. Same thing here, you multiply the 2 outside parts together, you get negative I times 3 is equal to negative 3I. The square root, you're not allowed to multiply by the inside there, so you just leave that alone. And there you go. So that is how you express one of these negative, square roots that has a negative underneath it. That's how you express it in terms of I. Okay, it doesn't mean you always have to do that. Okay, but if they tell you to do that, express it in terms of I, then you need to do what we've done here. Okay. Now, this is kind of something that's new down here. You might be wondering what's going on with this. Okay. Well, complex numbers, you guys, are written, not always, but oftentimes in this format here, a plus bi, where you have a regular number a plus a regular number times I. You can see we have a bunch of examples of that here. 3 plus 8i, a regular number plus a regular number times I. It could also be subtraction, a regular number minus a regular number times I. Okay, that's how complex numbers oftentimes are written. The reason why they're written that way is because it's one single format here that allows you to write something as a real number, because if the b part is 0, that would make this term disappear right here, and you would just have this part right here, which does not have an I in it. And if you have a number that doesn't have an I in it, it can't be imaginary, okay? If you don't have an I in your number, or something that's equivalent to that, okay, like the square root of -1, if it's just a normal number, like for example, if I got rid of the 8i right here and I just said 3, that's a real number, okay? So you could have a plus bi where the b is 0, which is the same thing as just getting rid of the bi, okay? It's kind of like the bi part, it's still there, but it's invisible, okay? That would be a real number. Whereas if the b is not 0, for example, if it's equal to 8, if you have 8i, then that makes this whole thing right here imaginary, because the 8 is still there. It's not invisible. It's actually there. And therefore, the 3 plus 8i then must be imaginary, because the 8 makes the I actually something that's actually there. It's not 0. It's not nothing, okay? And so that would go into this category here where b is not 0. So the real numbers and imaginary numbers together can both be written in the a plus bi format, and that's why we have that format. It allows all complex numbers to be kind of put into one group with one single format, a plus bi. So that's my little explanation there about why we have these numbers that look like that. Okay, a minus bi or a plus bi. Now, how do we deal with those numbers? Okay, thankfully, this should be review, but I'll review it here just in case. When you have a two terms, because that's what a complex number is basically two terms, because it's separated by a minus or a plus. When you got more than one term in a bracket, more than one term in this bracket here with plus in between, it's no different than if you had a bracket plus a bracket with polynomials inside, just normal terms separated by pluses and minuses, normal monomial terms. Okay, what was done in this case when you do a problem like this is you just combine like terms. However, when you got a term like a bunch of terms like a polynomial inside of each bracket here, but there's a minus in between, those are the problems where you change the middle to a plus, and then you change the signs of all of the terms inside of the second bracket. Okay, so bracket minus bracket, you change the signs of all the terms in the second bracket, then you combine like terms, because now it's a plus problem. And speaking of plus problems, if you have a bracket with a plus in the middle and then another bracket, you just combine like terms. There's no sign changing, you just combine like terms. It's exactly the same thing here in these next two problems. You just need to combine like terms because there's a plus in between the brackets. 7 and 3 give you 10. The negative 4i and the 8i, if you combine like terms there, you get positive 4i, don't you? Okay. And as always, when you combine like terms, make sure there's a plus or minus in between each answer there. When you combine like terms, because that was positive 4i, make sure to put that plus there. Now, as I just mentioned, when you have a bracket minus a bracket, you got to change the signs, not of the first bracket, keep that the same, 6 minus 3i. You make the middle into a plus, and then you change the signs of these two terms from negative positive to positive negative like this. Okay, now it is a bracket plus bracket problem, just like it was over here. So now you combine like terms, okay, and you get 6 and 4 is equal to 10. Okay, negative 3 and negative 9 is equal to negative 12. All right, and that's combining like terms right there. Okay, so bracket plus bracket, bracket minus bracket, that's what you do. Now, in this last one here, we got bracket times bracket. Okay, let's review that as well. When you have a bracket times a bracket, all right, that's like this plus. See how this is a bracket times a bracket, and each bracket has two terms in it, just like it does right here in this current problem. Okay, how was this one done? You multiply the first term in the first bracket by each term in the second bracket. That's these first two terms right here. Then you go over to the second term in the first bracket and you do the same thing here, okay, as I highlighted here with my my little semicircles right there, okay, that I drew. Negative 4y times 3x and negative 4y times negative 4y. And so you ended up with a total of 4 terms here. Put pluses and minuses in between them, and then you combine like terms if there are any at the end. That's going to happen here with one separate thing that we also need to do. I will highlight that. It has to do with the i's. Okay, we'll get into that. But let's do that same thing that we just looked at, where you start out with the first term in the first bracket. Okay, 6 gets multiplied by negative 2 and 5i, just like we did right there with the 3x. It gets multiplied by each of those 2 terms over there. 6 multiplied by negative 2 is negative 12. 6 multiplied by 5i is positive 30i. Put pluses and minuses in between. Then we go to the negative 3i, and we multiply by those 2 terms, just like we did here with the negative 4y. We multiply by those 2 terms. Okay, negative 3i times negative 2 is going to be positive 6i. And then negative 3i times 5i is negative 15i squared. Now, there's one additional thing that you need to do before you combine like terms. Okay, in this problem, you didn't have to do that. You just, after you multiplied, you just had to combine like terms, and then you were done. When you have an I squared, though, you guys, you have to realize that this is not your normal thing like we had in this problem. Okay, y squared is just y squared. There's nothing you can do with that. Okay, you can't compute that. But I squared is something you can compute, and so we need to do that. I squared, you guys, is equal to negative 1, as we saw at the very top of this page. I squared is equal to negative 1. And so therefore, we need to realize that negative 15 times negative 15 times I squared is negative 15 times negative 1. And so basically what this all means is that when you get a term with I squared in it, you take the number that's being multiplied by the I squared and you multiply by negative 1. So if this had been positive 15, you'd say positive 15 times negative 1. But because it's negative 15 times I squared, that means negative 15 times negative 1. Okay. Now you combine like terms. Okay, so do that I squared thing. Okay, multiply by the number that was in front of it there, being multiplied by it. Okay, just the number in front of it, not the additional terms over here. Okay, you're going to have either a plus or minus here. Just multiply the thing that is that thing that's immediately in front of the I squared, including the plus or minus, but not anything before that. Get that answer. If it's positive, put a plus there. Okay, then combine like terms. Negative 12 and 15 equals 3. 30i and 6i is equal to 36i. And so that, you guys, is how you multiply 2 brackets that have complex numbers in them with a couple of terms there from the complex numbers inside of each bracket. Okay. And so that concludes our discussion of complex numbers. All right. Just remember that thing about the I squared. All right, is one of the big things. Okay, and like I said, expressing each number in terms of I, do not just say, hey, that's not a real number. Okay, you need to acknowledge that that's an imaginary number and then go through these steps. Okay, and so that concludes once again our discussion of complex numbers.